Hello and welcome to reInvent 2020. This session is AWS at the Edge. I'm Saras. I'm a Principal Product Manager in AWS IoT. And with me today is Ath, who is a Manager of Renewable Optimization at Amazon. And today we're really excited to talk to you about AWS at the Edge and how Ath's team is using AWS IoT Sitewise to optimize operations at our wind farms. So the agenda for today, we'll cover an overview of AWS at the Edge. We'll then talk about industrial edge solutions using Sitewise. And then I'll hand it off to Ath to talk to us about how his team is helping Amazon reduce our carbon footprint and how they're using Sitewise to optimize operations at these wind farms. Okay, so to get started, let's define what is the edge. At AWS, we define edge broadly. It's about pushing the cloud infrastructure out to the edge so we can help our customers move data processing and data analysis closer to where it is generated. So it opens up a host of high-performant edge applications and edge use cases for them. Examples can be a device running out in the wild, running on FreeRTOS, or it could be a local data center or a local facility where we have infrastructure deployed. So this broad definition is able to get us to a broad set of edge solutions. Now let's talk about why is edge important for customers. So it's all about centralized management, but decentralized execution. Bringing this processing and analysis closer to where the data is generated opens up a host of high-performance edge applications that customers can utilize to get to business outcomes. Now, this can include local processing, machine learning at the edge, filtering data before it gets to the cloud. There's a host of use cases that can be applied at the edge as well as at the cloud. So there are applications that you can develop in the cloud and then deploy them anywhere. You can run them on outposts in a data center, you can run them on one of our POPs, or you can run them at the rugged edge. Next, I wanted to share some quick facts on the growth of the edge. So cloud has delivered on the promise of agility, elasticity, cost savings, and the ability to deploy globally in minutes. So cloud solutions have matured over time. Use cases have emerged across industries that allows customers to combine these cloud resources and then add some local element of processing and filtering at the edge. This data from IDC shows that by 2023, we expect to see a 70% jump in enterprises using data processing at the edge for IoT. By 2024, expect to see an 800% increase in the number of enterprises that are deploying applications at the edge. So we see this popularity of edge use cases, and the same is also reflected in the forecasts for IT infrastructure. So needless to say, we see a lot of traction with edge use cases, and the popularity is just growing over time. So what are some of these use cases? Some of the use cases for edge is, when you cannot wait, your applications cannot wait for the data to do a round trip from the cloud, or you are in cases where the internet connectivity is intermittent. There may be cases where it might not be feasible or frugal to upload data to the cloud because maybe your manufacturing line or manufacturing site is generating terabytes of data, and you are unable to upload data to the cloud because the devices that you're collecting data from are operating in regulated environments such as in hospitals. Most of these applications, they rely on the cloud for processing, storage, analytics, but there is also cases where some of this functionality needs to happen at the edge. For example, when you want to run machine learning at the edge, really close to where the data is being generated. So you can build applications that are fast, that are intelligent, are real-time responsiveness, and then it just reduces the amount of data that you're uploading to the cloud. So on this slide, you see a couple of examples of the use cases. One that's shown here is the robot vacuum by iRobot, the Roomba vacuum, sorry. And it needs to be able to see obstacles and respond to them in real time. Or you can see use cases in autonomous vehicle where data is being collected and needs to be processed from a multitude of sensors on the vehicle, and it needs to do that without being connected to the cloud. So these are some examples of edge where edge is popular and is applicable for use cases such as this. So what are some of these requirements for these use cases? Security, obviously, is paramount to us. Use cases like healthcare, where it's highly regulated, security is top of mind for our customers. And we have years of experience managing security in the cloud at scale. And that same security posture is extended to the edge. In addition, there is specific security enhancements and security features available that are applicable at the edge as well. And then the ability to develop once and deploy anywhere, wherever you need it, is really powerful. Our edge offerings work seamlessly with our cloud services, so you can build your business applications exactly with the setup that you need. These can be applications that are latency sensitive. So you might need a single-digit millisecond latency for quick action. You can have assets with limited connectivity. This is very relevant in the IoT world, especially in the industrial sector, when you're thinking of areas such as a mine or an oil rig where you might have intermittent internet connectivity. Sorry about that. And then finally, for cases where you just are generating a ton of data and it's just not feasible to upload all of that. So being able to filter and aggregate data before uploading it to the cloud is another very valid use case for developing on the edge. Now, I wanted to give you a sense of what are all the AWS services that play a part at the edge and are part of the edge offering. So you see from this graphic, the edge offering spans a lot of different services and a lot of different categories at AWS. So you see on the left where you are extending the cloud infrastructure, using AWS Outposts, for example. And on the right, you have devices out running in the wild, running on free RTOS, for example. And you see from this graphic how they all just interact with each other. Okay, now we'll shift gears a little bit and we'll focus on the industrial IoT solutions. Our customers asked us, how do we derive more value out of our industrial data? And the challenge is data collection and data aggregation is at the edge across different sources, across different sites, or across different factories. It's really hard to build and maintain. On-premise historians are often isolated and locked such that it's really hard to create a centralized data repository from where this data can be utilized by users or it can be used by applications. And these applications could be, local to a specific site, or it could be across sites at a company level. So we launched AWS IoT Sitewise earlier this year to solve just that. Sitewise is a managed service that helps you easily collect, organize, store, and monitor data from industrial equipment at scale. And this helps you make better data-driven decisions. With Sitewise, you can make sense of your industrial data coming out from the machines by attaching additional context to it. You can also get real-time insights from your machine data and finally be able to visualize and share that machine data and insights to users in your organization. Now, I'm sure you're all thinking, but how? So let me tell you how Sitewise works. So you can deploy Edge Gateway software locally, and that connects to your local system, extracts data using popular industrial protocols, and uploads it to the cloud. And in the cloud, you structure that data. You can do it hierarchically using asset models. Asset models also help you configure and compute, common performance metrics such as overall equipment effectiveness, or create and manage your alarms based on this machine data. The data in Sitewise is stored in a managed, performant, time-optimized data store. So your applications and your downstream workloads have a consistent way to read this data. And then finally, Sitewise also offers a really simple no-code solution to get this data in the hands of the operators at your company by helping you create dashboards that are fully managed and allows you to visualize this data in the format that makes sense to the users. Now I'll double click a little bit on Sitewise Monitor. Sitewise Monitor, as I mentioned, fully managed applications that allows you to visualize and interact with the data that's already connected to AWS IoT. It's a web application. That means you can use it outside of the AWS console. You don't have to log into AWS console. And then the users are able to visualize it on their laptops, on tablets, or phones, or any device. And it's just so easy to get it set up. Some of the benefits with Sitewise Monitor: you can set up and deploy your applications, unlocking the potential of your industrial data in a matter of minutes and without writing any code. You can also discover your assets, you can visualize the data from them, and you can get insights to it really quickly. You can easily share these dashboards with users in your organization in a secure way. Sitewise Monitor supports single sign-on authentication, so it connects to on-premise Active Directory or SAML providers, so users can just use their corporate credentials and just get started really quickly. So in the next slide, this is a video of how a user is going to interact with the dashboard. So you can see that they're setting up the dashboards, drilling into the data, very easily going back in time to see what has happened over a span of time or what has happened in the past. And you can see that they're using different types of visualizations and chart types to represent the data exactly how they want it, and they're doing all of this without writing any code. And for those of you who've been following along with Sitewise, maybe you were confused when I mentioned alarms. Well, we just launched alarms, industrial alarms for Sitewise in preview. With the new industrial alarms feature, operations team can create and manage alarms on any Sitewise data. All you have to do is pick the properties, set up a rule, and set up the users that need to be notified when the alarm goes off. So we support SMS messages and emails out of the box, but you can also extend that to any ticketing mechanism using Amazon Simple Notification Service or SNS. And when the operator receives a notification, they can interact with that data and they can interact with the alarm by acknowledging it, by snoozing it, and the history of the alarm is also available. So it allows you to query and look at how you can query the data and you can see how the state of the alarm over a period of time. And again, this feature is available both from the AWS console and from the Sitewise Monitor applications. So you have the flexibility to set up these alarms and manage the alarms from whatever platform you're looking at. So you could be a developer or it could be an operations professional who's looking at just the dashboards. So there's a lot of flexibility there. This is a quick view of how users would see these alarms on their dashboards. On the top right, you see all your alarms, and you can visually and very easily identify what states they are in. So yeah, I highly encourage you to get on the console and try out this feature. Now I'll take a few minutes to talk about some of the enhancements that we've made in Sitewise specifically at the edge. First, I think I'll talk about the two new protocols that we support. So previously, Sitewise supported the OPC UA industrial protocol. And with this launch, we're also adding support for Modbus TCP and Ethernet IP, giving you a lot of flexibility in the data collection for Sitewise. So you don't have to go through any protocol conversion then before getting the data into Sitewise. Next, we've also made updates to the OPC UA connector. Specifically, we've made 3 updates, and I'll talk through all of them. The first one is configurable scan modes. So you can choose between a polling mechanism or a subscription mechanism. Polling mechanism is the new one, and with the polling method, you can specify a time interval when the data should be polled, and the data is collected even if the values are not changing. Second, we've also introduced a mechanism for you to refine your ingestion frequency even further by specifying custom scan rates. And finally, you can set up deadbands on the gateway, so the gateway will filter the data for you. And you can set it up as absolute deadbands or percentage deadbands. These features together just give you more flexibility and more control over how frequently and what data is uploaded to Sitewise. And finally, you can perform custom processing, custom transformations, aggregations, and filtering at the edge using Lambda functions. This is a feature for a custom stream destination where you can point the Sitewise gateway to act on the data locally using Lambda functions deployed at the edge. And I'm imagining the audience chanting more edge, more edge. So if you were, I hope you were able to catch our announcement for the preview launch of AWS IoT Sitewise Edge. If not, I highly recommend you check out the IoT leadership session by Dirk. With AWS IoT Sitewise Edge, you can choose to leverage the power of Sitewise, including data collection, asset modeling, and monitoring, and you can do all of that at the edge. And why would you want to do that? What are the benefits? Well, it gives you access to low latency monitoring and analytics. No internet, no problem. You can have your edge workloads remain uninterrupted even if there is problems with your internet connection. And then you have the flexibility to aggregate and filter the data before you upload it to the cloud. So now with the help of AWS IoT, you know the state of all the things and you can reason on top of that data. So what problems are you going to solve today? And with that, I'll hand it over to Ath to talk to us about how Amazon Wind Farms is using Sitewise to optimize operations. Over to you.
Thank you, Saras. My name is Ath, and I lead the Renewable Optimization team at AWS. My team is responsible for managing the global renewable portfolio and improving the monetization of our renewable assets. This requires us to have a software platform that monitors our renewables in real time and a software system to help us improve the monetization of electricity generated. I am here today to share with you how we use some of the AWS services to help us perform our jobs, specifically AWS IoT Greengrass and AWS IoT Sitewise. Before I dive in, I wanted to share with you that in September of 2019, Amazon announced the Climate Pledge. The Climate Pledge is Amazon's commitment to reduce our carbon footprint and become net zero carbon by 2040, 10 years ahead of the Paris Agreement. As part of the Climate Pledge, Amazon will run on 100% renewable energy by 2025, 50% shipments net zero carbon by 2030, and in June of 2020, Amazon announced the Climate Pledge Fund, a dedicated investment program with an initial $2 billion in funding to invest in visionary companies whose products and solutions will facilitate the transition to a low carbon economy. In order to meaningfully reduce the amount of net greenhouse gas emissions, low carbon solutions need to be developed in all sectors of the global economy. The Climate Pledge Fund will invest in companies in multiple industries with an initial focus on transportation and logistics, energy generation, storage and utilization, manufacturing and materials, and food and agriculture. And for sports fans out there, Amazon has secured the naming rights to Seattle's upcoming NHL team and WNBA team, the Seattle Storm, which will be called the Climate Pledge Arena. It will be the first arena to be certified net zero arena in the world. It will be powered by 100% renewable energy, and all operations and events at the arena will be zero waste. One of the first tools we have to lower customer carbon footprint is migrating them to AWS. In 2019, AWS commissioned a report on carbon emissions of the cloud versus typical enterprise data centers, which found AWS is significantly more energy efficient and has significantly smaller carbon footprint than most US data centers. 61% of carbon reduction is attributable to more efficient servers and higher server utilization. We have the economies of scale to be able to run servers at close to full load and with very little waste. 11% of carbon reduction is attributable to more efficient data center facilities. And 17% of carbon reduction is attributable to reduced electricity consumption and renewable energy usage. Because we control all of our own AWS data centers and supply chain, we can rapidly roll out efficiency improvements around the world. The numbers will improve as we get closer to our climate pledge goals, and every one of our millions of AWS customers will automatically inherit those benefits. Today, Amazon has over 90 renewable energy projects across the world. These projects have the capacity to generate over 2,900 megawatts of energy annually. That is enough to power 680,000 US homes. We have wind farms in California, Texas, Indiana, Ohio, North Carolina, Ireland, Scotland, and Sweden, along with many on-site solar facilities and off-site solar facilities, including in Virginia and Spain. My team is responsible for improving the performance of our large renewable portfolio. A foundational requirement to perform this job is having access to high-quality data. In our roles, we need access to real-time data that shows the current operating conditions at the plant and metrics to help us identify any issues at the project, and this ensures the facility is performing as expected. Beyond monitoring metrics from our plants, we also spend a lot of time improving the forecasts and delivery of electricity on the grid. We use generation output along with availability and run those through ML algorithms to improve the accuracy and profitability of our generation forecasts. To perform all these jobs, we needed a software platform that would collect large volumes of real-time data from many different sources and protocols and store all that IoT data in an efficient way that would allow for fast retrieval. With IoT Greengrass, we can connect to multiple protocols such as OPC UA, OPC DA, Modbus, and APIs. And with IoT Sitewise, we can perform the job of an historian to store all IoT data in the cloud and allow for fast retrieval of the time series data. Of particular interest to my team is the ability to manage all these different connections through the AWS console and all the different protocols through a centralized approach. Now, once we have all this data, we needed a tool to help us display the information so we could look for anomalies. So of particular usefulness to our team is the Sitewise Monitor dashboard, which enables users to create dashboards on the fly and view all real-time and historical data, we especially like the no-code way of building the dashboards. And I'll demo that feature in a moment. Additional benefit to Sitewise Monitor is its ability to create single sign-on access so all users across the organization can view the same metrics. There are three major features I like about IoT Greengrass and Sitewise. I mentioned the connectors and the ease of support in managing all those connectors, the Sitewise Monitor dashboard that provides most of the functionality we want, and finally, a key component to our team in providing is providing a mechanism to export data from Sitewise into a data lake format. This is probably one of the hidden gem features of Sitewise. We can spend a lot of time managing real-time data in the data lake, and Sitewise enables us to export the data to S3 and automate that workflow. This is key to our team, as our business users and our data science team needs access to historical data in an easy-to-use format when building their reports or working on machine learning models. Once the data is exported to S3 and Data Lake, it can be easily queried by Athena and pulled into Jupyter notebooks for model building. So now let's dive into a live demo. So here's the Sitewise Monitor dashboard screen, where you can view all your dashboards and create new ones on the fly. As I mentioned, we were looking for a tool where we could monitor real-time streaming data and create key KPIs to track the performance of our renewable projects. So let me show you an example of how I can create a dashboard. So this is the dashboard creation screen where I'll go into here and I'll create a name for the dashboard. I'll call it reInvent Live Demo. And from here, I can drag all the properties that I'm interested in on the screen. So wind speed is obviously very important for a wind farm. So I'll put that on here. I also like looking at wind direction. It sometimes gives you good perspective of the quality of the wind. And let's put in a cell position just for good fortune here. And I'll change this widget from a line graph to a KPI widget. Then drag it across. And then below that, I'll put in power, obviously very important metric for a wind farm, and wind speed. And I'll drag that across. And let's take a look at wind direction, see how those two relate with each other today. And that's it. That's how you build your dashboard. I'll save it here, and then we'll move on to the live dashboard with live data. So I typically look at a screen on a daily basis. So I'll select the last day, and I'll scroll down. And what we're looking for in this type of dashboard is really the power output from the facility and looking for any deviations to expected generation. This all looks pretty normal. The power is fairly stable when the wind speed is strong, starts to taper off as the wind speeds decrease. Wind direction is also a critical factor for quality of wind. And so that's something we'll look at in various wind sites depending on that affects the power generation in certain times of year. So the great thing for me with this widget is the ability to zoom in. So I can zoom in different time ranges. So I just select here, and the application is very responsive. So I really like that about Sitewise Monitor. So I don't see anything anomalous here at all. It looks fairly straightforward with low wind speeds. But I'll show you another dashboard that I've built. So I've built several over here. The one I like is really when I identify a problem with a turbine. For example, I'll start out here, and on this dashboard, I have the live generation from all the different turbines spread out across different widgets. I like looking at this to look for problems. So I will look at it over the past 7 days, and I'll look for turbines that have unexpected behavior. Here's an example of one. So it looks like turbine number 5. And so from this dashboard, I'll go back to my dashboards and I'll drill down on one specific turbine and zoom out to that turbine and check to see what happened in that particular time interval. So from here, I can zoom in. There's a blip on the operating state here, so the operating condition changed at the wind site. I'll zoom in here, and I really like how responsive this application is. And from here, I can see that the normal operating state, which is 3, went down to 1, and from there, you can see that the power output dropped. And so this is a dashboard that I would use if the power unexpectedly dropped. I would go in, I would check to see which turbine was affected and what the operating state was for the particular condition, and then use that to for diagnosis of potential problems at the facility. So in conclusion, my team has been pleasantly surprised with AWS IoT Sitewise and its ability to meet some of the needs of our business. Of particular note, I found it very easy to use, especially building dashboards. I really like the ability of managing all the various connectors through one simple user interface through AWS Console. And I especially like the historian capabilities that enable us to move this time series database from a historian to our data lake model where we can run advanced analytics. I'm really looking forward to all the progress the IoT Greengrass and Sitewise team is going to make going forward. And this looks to be a key component to our software platform to manage our renewable portfolio.
Thank you, Ath. We have tons of great resources on our website if you'd like to learn more, including a resource library with ebooks, webinars, blogs, and a lot of really good content. I'd also encourage you to check out other IoT talks if you want to learn what's going on in the IoT world. And from both Ath and myself, we thank you for watching and have a great rest of your year. Thank you.